Hi everyone, my name is B. Varun. I am from CSCD section. Today's my concept video topic is Principle and Operation of DC Generator. The contents in my topic are what is generator, what is DC generator, parts in DC generator, types of DC generators, working and working principle and operation of DC generator, EMF equation of a DC generator, construction of a DC generator, applications of DC generator, and finally conclusion. Now moving on to the next slide. What is a generator? Machines that convert mechanical energy into electrical energy are called electric generators. The electrical energy generated is further transmitted and distributed to power lines for domestic and commercial use. There are two types of generators: one AC generator, two DC generator. A DC generator is the type of electrical generator that converts mechanical energy into direct current electricity. However, a generator that converts mechanical energy into alternating el- current electricity is an AC generator. That means the generator that converts mechanical energy into alternating current, it is called as AC generator. Now, moving on to the next slide. What is a DC generator? A DC generator is an electrical machine which converts mechanical energy into direct current electricity. In DC generators, the energy conversion is based on the principle of dynamically induced EMF production. These generators are most suitable for off-grid applications. DC generators supply continuous power to electric storage instruments and power grids. Now, moving on to the next slide. Parts in a DC generator. DC generator consists of the following parts: stator, rotor, armature core, armature winding, field coils, yoke, poles, pole shoe, commutator. Now, Getting into the details of the parts, stator. A stator is a set of two magnets placed in such a way that opposite polarity faces each other. The purpose of the stator is to provide a magnetic field in the region where the coil spins. Rotor. A rotor is a cylindrical laminated armature core with slots. Armature core. The armature core is cylindrical in shape and has grooves on the outer surface. These slots accommodate armature winding in it. Armature winding. These are insulated conductors placed in the armature core. Because of them, the actual conversion of power takes place. Field coils. To produce the magnetic field, field coils are placed over the pole core. The field coils of all the poles are connected in series. When current flows through them, adjacent poles acquire opposite polarity. Now, moving on to the next slide, yoke. The outer hollow cylindrical structure is known as a yoke. It provides support to main poles and interpoles and gives a low reluctance path for the magnetic flux. Poles. The main function of the poles is to support the field coils. It increases the cross-sectional area of the magnetic circuit, which results in a uniform spread of magnetic flux. Pole shoe. To protect the field coil from falling and to enhance the uniform spread of magnetic flux, pole shoe is used. The pole shoe is fixed to yoke. Commutator. The commutator is cylindrical in shape. Several wedge-shaped, hard-drawn copper segments form a commutator. The functions of a commutator are to connect stationary electric external circuits to the rotating armature conductors through bushes, and to convert induced alternating current into direct current. Now, moving on to the next slide, types of DC generators. DC generators can be classified into two main categories: separately excited self-excited, separately excited. In this type, field coils are energized from an independent external DC source. Self-excited. In this type, field coils are energized from the current produced by the generator itself. Initial EMF generator is due to residual magnetism in field poles. The generated EMF causes a path of current to flow in the field coils, thus strengthening the field flux and thereby increasing EMF generation. Self-excited DC generators can further be divided into three types: series wound, shunt wound, compound wound. Series wound: field winding in series with armature winding. Shunt wound: field winding in parallel with armature winding. Compound wound: combination of series and shunt winding. Now, moving on to the next slide. Working principle of DC generator. How does a DC generator work? Here is a rough, rough diagram of a DC generator. Now, moving on to the next slide. Working principle and operation of a DC generator. According to Faraday's laws of electromagnetic induction, whenever a conductor is placed in a varying magnetic field or a conductor is moved in a magnetic field, and EMF, electromotive force, that's induced in the conductor. The magnitude of the induced EMF can be calculated from the EMF equation of DC generator. If the conductor is provided with a closed path, the induced current will circulate within the path. In a DC generator, field coils produce an electromagnetic field, and the armature conductors are rotated into the field. Thus, an electromagnetically induced EMF is generated in the armature conductors. The direction of induced current is given by Fleming's right-hand rule. Now, moving on to the next slide. Here we can see the rough diagram, case 1, and this is case 2. According to Fleming's right-hand rule, the direction of induced current changes whenever the direction of motion of the conductor changes. Let's consider an armature rotating clockwise and a conductor at the left is moving upward. When the armature completes a half rotation, the direction of motion of that particular conductor will be reversed to downward. Hence, the direction of current in every armature conductor will be alternating. If you look at the above figure, you will know how the direction of the induced current is alternating in an armature conductor. But with a split ring commutator, connections of the armature conductors also gets reversed when the current reversal occurs, and therefore we get unidirectional current at all at the terminals. EMF equation of a DC generator. The EMF equation for DC generator is expressed as Eg is equal to P phi Nz divided by 60A, where Eg is generated EMF across any parallel path. P is total number of poles in the field. N is rotational speed of armature in RPM. Z is total number of armature conductors in the field. Phi is magnetic flux produced per pole. A is number of parallel paths in the armature. Now moving on to the next slide. Applications of DC generators. The applications of DC generators as follows. The separately excited type DC generator is used for power and lighting purposes using the field regulators. The series DC generator is used in arc lamps for stable current generation, lighting and booster. Level compound DC generators are used to supply power to hostels, offices, and lodges. Compound DC generators are used for supplying power to DC welding machines. A DC generator is used to compensate for the voltage drop in the feeders. Now, moving on to the next slide. Conclusion. I conclude that the working principle of the DC generator is based on Faraday's laws of electromagnetic induction. Now, moving on to the thank you slide. Thanks everyone.